This is a phenol red broth. Phenol red is the name of a pH indicator. The indicator changes color in response to the acidity or alkalinity of the media. When microbes ferment carbohydrates, acid byproducts are produced that lower the pH of the broth, which causes a color change. This tube is labeled indicating that the media contains dextrose. Dextrose is another name for glucose. This is a sugar molecule, and in this broth it is the only sugar available to the microbes. Some microbes can ferment glucose, other microbes cannot. Within the broth tube, there is a smaller glass tube called a Durham tube. The tube is inverted, with the opening at the bottom of the broth tube. Another byproduct of fermentation can be gas, so the Durham tube is there to capture any gas that might be produced. This PR broth contains lactose as the sugar. And this PR broth, with the white cap, contains mannitol as the sugar. Here is the Durham tube shown moving side to side. The inoculating procedures are very similar to other procedures we have performed. The most significant element is the liquid nature of the broth. Here I am preparing my tubes and sterilizing the loop. Since we are moving microbes for growth, it is very important that you let the loop cool down completely before obtaining the microbes. When we go to pick up microbes from the culture tubes, we want a visible amount on the loop. And when handling the broth tubes, it is extremely important that you hold the tubes at an angle or the broth will pour out. Submerge the loop into the broth and agitate the loop side to side a few times. You may see the microbes get washed off of the loop, but this is not necessary, as long as there has been adequate contact. Thinking back to smear preparation, you should remember that the loop is capable of holding a quantity of liquid. This is the most significant contamination issue when working with broths. If the loop is withdrawn with broth held in it, that broth will contain a great number of microbes and can easily fall off. The solution is to agitate the loop while still inside the tube so that the broth is knocked out. Do not be too vigorous, or you could end up splashing the broth out of the tube. Here is the procedure repeated for my second microbe. Once the transfers are complete, secure the lids of the tubes. This first result is alkaligenes faecalis in the dextrose phenol red broth. This microbe is known to be negative for this test, meaning that the microbe cannot ferment dextrose, otherwise known as glucose. As a result, no acid was produced, so there was no colour change. Because the microbe could not ferment glucose, there was also no gas produced, as noted by observing the Durham tube. The second tube is Staphylococcus epidermidis, also in the dextrose phenol red broth. This microbe is expected to be positive for this test, meaning that the microbe can ferment glucose and produce acid. The expected colour change is red to yellow. However, as you can see here, the broth is orange. It could be the case that the broth was not incubated for long enough. Typically, orange is an inconclusive result and would need to be repeated. Here is the expected result from S. epidermidis. The acid products of fermentation have lowered the pH of the broth and the indicator has turned yellow. This is Enterobacter aerogenes in the dextrose PR broth. The microbe has been able to ferment glucose to produce both acid and gas. When testing the unknowns, we are only testing the ability of the unknown to produce acid from fermenting the sugar. Gas production is not considered in the unknown test key table.